This is pre-calculus notes on section 3.1, domain convention. Here is the domain convention. Unless shown to the contrary, the domain of a function consists of all real number inputs that produce a real number output. And so when you're looking for the domain, that's what you're looking for. All of the values that you can use as an input that give you a real output. Below the domain convention are a couple of the most obvious, most common reasons why you would not get a real number output. And there are just two of them, really. Division by zero, and if you're taking the even root of a negative number. So those two conditions give you not a real solution, or not a real number solution, and so therefore if there's any inputs that give you those possible outputs, you want to uninclude them in your domain. All right, let's see, is there anything else here I have to show you? No, that's it. All right, so let's move on to some problems. All right, here's the first problem where we're finding the domain, okay? And so we are looking for two things. We are looking for division by zero, and we are looking for the even root of a negative number, okay? So there's no roots in this, but there is a division. So what we're looking for is when will the denominator be equal to 0? Because if the denominator is equal to 0, you don't have a real output, all right? So I'm going to take the denominator. I'm going to set that not equal to 0. It can never be equal to 0. I want to solve for x. So x cannot be equal to -4, all right? That's the only restriction on the domain. So therefore, the domain is all real numbers except x cannot be equal to -4. That's the answer. All of the real numbers except -4. Next problem. Again, we're looking for to uninclude or restrict the domain in two possibilities if we're taking an even root of a negative or if we're dividing by 0. Here we've got an even root. So let's see, where is the radicand negative? Or let me rephrase that. Where is the radicand either greater than or equal to 0? Because these are going to be the numbers that we are going to include. Okay, if we were to write it the other way, if we wrote 1 minus 3w is less than 0, these would be what we would exclude. Okay. So instead of talking about what we're going to exclude, let's talk about what we're going to include. We're going to include all of the numbers that would leave the radicand greater than or equal to 0. Well, let's solve for w there. So I'm subtracting 1. I'm dividing by -3. So if w is less than 1/3, then our radicand will be positive. And so therefore the domain, okay, again, these are the numbers we are including. The domain is going to be all of the real numbers that are less than 1/3. Okay, 3 problems. You might want to pause this video and see if you can handle these by yourself. And then I will solve them. So you can just hit play when you're ready. All right, so problem number 3, where again we are looking for division of 0 and the even root of a negative number. Problem number 3 has neither. There's no division, there's no even roots, and so therefore the answer is all real numbers. Problem 4, there is no division, but there is an even root right here. All right, so here our radicand is x, and we want that radicand, this is again, I'm going to look at what we're going to include. I want that radicand to be greater than or equal to 0. And here there's nothing to solve for, it's already solved. So my solution, the domain, is all real numbers where x is greater than or equal to 0. Problem number 5, there is a division. There are no even roots. So let's just take the denominator. The denominator cannot be equal to 0. Again, there's nothing to solve for. These 3 problems I made were very simple. So here the domain is all real numbers where u is not equal to 0. And I think that's the last problem. Okay, that's it.